All right, so in this video, I want to cover the site selection model that we built for Ocean State Job Lot. So step one, whenever we do the site selection process, is to identify where you currently are and then just learn from your existing sites. That's the whole goal of the machine learning model is let's look at your existing sites and figure out what's working. So here we're on your website, we scraped it, got all the existing locations, and then what we want to know is something about each one of these sites. So to do that, we combined your existing locations with a cell phone study that went and grabbed all the cell phones in the past 12 months that stayed there longer than roughly 8 minutes. So now that's what you see on the map. The bigger the dot, the more cell phones are coming in and out of your existing location, and the smaller is just the reverse, right? So you got a gigantic dot over here, another one over here in Poughkeepsie. Probably the biggest one is this guy over in Barnstable, it looks like, next to the airport. You got a TG Maxx and all that stuff around it. But here we've got a good proportional dot list of just these are your successful sites in terms of foot traffic and not so much visited. So this is what we're trying to have the model solve for. Why? Like, why is this guy small and this one's big? So to do that, we ran a 1 mile radius ring around each one of your sites and just said, hey, what's the total population? What's the income like? What's the age, race, level of education? We're trying to absorb everything that's going on around your site to try to explain maybe this is the reason why some are visited more. So we did a 1 mile, a 3 mile, a 5 mile, a 5 minute drive time, a 10 minute drive time. All of these bands and different distances were just saying, tell me about the world around each one of these sites. And now find the commonality that all these big dots have in common. So that's exactly what we got here on this list. So here are the top variables that are correlated to overall store visitor count. You can see how much money in the area. And some of these machine learning variables, they get kind of weird, but it just finds a correlation, right? So how much money in an area around your site is being spent on audio visual equipment and services and online gaming services? The next highest one, well, how many companies are large establishments around you that are retail trade that specifically sell apparel and accessories? Then we're bringing in some of the Experian credit card data. So every single household in the United States is put into one of 71 socioeconomic buckets, and Experian does this based on all the stuff that Experian has about you, which if you ever try to get a loan in the United States, you've been queried by Experian or Equifax, and I think there's another one. But these three big credit bureaus, they know how much money you make. They know whether you pay child support, alimony, you name it. They know a lot about you when you take out a loan. So taking all that information into consideration, they go into putting every single household, and again, into one of 71 socioeconomic buckets. Here, I've got a little JPEG that shows you the 71 socioeconomic buckets. So I call them my periodic table of human beings. As you go from the top left to the bottom right, you're going from the politely named haves to the have-nots. You've got AO1s. You can go and zoom in on it and say, hey, look, the wealthiest households. Then all the way to the not so wealthy S71. You can see these are mature singles, limited income, concentrated in inner city apartments. So this is the socioeconomic stack in the United States. And it looks like out of all the variables we ran, this one right here, exposure to Q65. So if you want to know more about this type of customer, it's these guys: discount shoppers, retirement communities, TV entertainment, they're tech novices. This on page 4 is a wealth of information about how these people spend their time, their money, a little bit about their everyday life, right? Like this is what they go through every single day, just a glimpse into it. So all of this is just using consumer credit data, where you are, age level, ethnicity, all that goes into putting you in these buckets. So here we've got a list of all the top variables that we're searching for. Now what we want to do is start weighting them appropriately and seeing what sticks. So we do a big machine learning model, say do a combination of all these variables in various orders, and now let's see if we can come up with a good model. And here we're trying to build one to explain, again, the visitor count in each one of your sites. Two main variables that I want to focus on, and the report is just we're trying to predict the number of visitors, and we've got a correlation value of 0.74. One would be perfect. We can explain the variance to a T amongst all your sites. But 0.74, imagine it like we're 74% accurate at trying to figure out the variables and the different combinations that can explain visitor count or the variance from all your sites from one to another. Now that we got a good confidence level in the model, this is fantastic. If you had 0.95, That's what they use for medicines, right? Like you want a predictive value to be extremely high with a medicine or any kind of, uh, yeah, any kind of medicine, anything in the medical world, you want a high correlation value. But for retail site selection, having a confidence level of 74%, that's awesome, right? If we're at zero point 0.5, you could say we're guessing. We don't really have a good value or a good model, but 0.75, I would take those odds in Vegas all day. So we got a good correlation value. And now we're looking at the mean absolute percentage error, also known as the MAPE. And so when we do take a guess and we're trying to overall predict the number of visitors, we're going to be up or down roughly 16%. And so this is the accuracy of the model. I would say this is damn good, right? This is good for site selection to try to figure out where your next site should be. So now that we've gone over the model, let's see the end result. So after we learn from all of these sites and what we're trying to find, we then place that model on every single intersection you could possibly ever go, right? So that's the great thing about having a computer is you can just simulate situations. So we place that model every single intersection you could possibly open up a new location throughout the entire United States. This thing is a supercomputer that we built. So this is how we're able to do the simulation is you've got to have a beefed up computer to run this machine learning model and feed it possibly every single place you could go. And then we scored it based upon the model. Before I get into the specific intersections, we aggregate these intersections to give you a complete market point of view because every single intersection could be overwhelming. But at first, you just want to identify key markets that you could potentially go into. So I'm going to go ahead. Let me turn off this labeling real quick. It's getting in the way. So here we have a color coding system. Wherever you have purple, those are going to be markets that are not as similar or this formula to success that we can explain by your Northeast sites, right? I don't think this place right here in Nebraska has a lot of commonality with your East Coast presence that you're predominantly in. So all the other purple areas like Mississippi and this whole area, probably not a good market to expand into or just a good old region. You know, Tucson looks like it's light green because we're looking for the darker the green, the more we want to go there. So yeah, San Francisco Bay Area could be more similar to what you're experiencing over on the East Coast and find like commonalities and potential new stores based upon the data we're gleaming from your existing. Now let me turn back on this labeling. So wherever you have a score of 100, that's the highest value. And then you've got all the other percentiles. So, hey, could Dallas work? Yeah, it gets a score of 83. Tucson gets a score of 87 in the general market. Over here in Colorado, this area, it gets a score of 90. So we could then zoom into this market and then turn on that retail growth visits. So out of the entire state of Colorado, now you know where in that general region. So this whole area in this quadrant gets a score of 90. Over here, as you go to Montrose and everything over to the west, that's not a good predicted market. It looks like as we zoom in, hey, should I go to Denver or maybe Colorado Springs? Well, we're getting a higher measure for a possible site in this Colorado Springs area, specifically this area. So as we zoom in, we'll get an aerial that turns on so you can start identifying real estate sites that happen to fall in and around. This is the core of the area if you were to go to Colorado Springs as justified by the previous thing. So now you can start to identify real estate and say, okay, what's available? What's the cost? What's the timing to get in there? This is what the site selection model's goal is trying to do is just give you a pathway and a plan to start tackling the expansion. Let me know if you got any questions.